Hi everyone, I am Ms.V.ATCHAYA, Assistant Professor of Geology, A.D.M. College for Women, Autonomous, Nagapattinam. Today we will discuss about the topic of igneous petrology. Okay, we will discuss about the igneous petrology briefly in our content. Shall we go for the content? Rock. First we talk about rock. Rock is a naturally acquiring a solid aggregate of minerals of mineraloid matter. Okay, it's a fundamental component of the Earth's crust and the classified based on the minerals. Example, it contains chemical constitution, chemical composition, and how it was formed. It is based on the how it was formed. The rock is classified. Rocks are classified as three types. First one is igneous, second one is sedimentary, third one is metamorphic. Igneous is comes under the directly volcanic rock. Directly comes under the volcano. If it is volcano solidification in the magma under the earth's surface, it is called intrusive igneous rock. If the volcano have erupted directly above the earth's surface, that comes along with the lava, that lava solidified and becomes a extrusive igneous rock. Okay, rocks are crucial for understanding Earth's history. So rocks are important components for understanding our Earth's history and our Earth's composition and their process. What are the processes are happening in our Earth are based on what are the rocks are there. They provide clues about past environment. So rock gives clues about our past environment, tectonic activity, and the evolution of life. How the lives are evolved in our Earth. These are the clues are given by rock. Next, igneous petrology is the study of magma and the rocks or solidification from the magma. Thus, igneous petrologists are concerned with the entire spectrum of process that describe how magmas are produced and how they ascend through the mantle or crust, their mineralogical and geochemical evolution, okay, and their eruption or emplacement to form igneous rocks. Igneous petrology requires working knowledge of mineralogy. So if we read igneous petrology or we study about igneous petrology, we need a vast memory of minerals. So minerals also important for shall we study in the igneous petrology. So mineralogy also important topics for before studying igneous petrology. Igneous rocks are divided into general categories. Okay, general categories of plutonic, hypabyssal, and volcanic. Depending on the grain size, we are classified them as volcanic, hypabyssal, or plutonic. Okay, plutonic rocks are how classified. Plutonic rocks characteristically have cores are medium grain. So cores to medium grain. Igneous rocks comes under the plutonic region. The coarse grains are present are coarse to medium grains. If examples greater than 1 millimeter, the grain size are greater than 1 millimeter, they are comes under plutonic conditions. And they are inferred to have a crystallized in the deep of the crust. So plutonic rocks are formed under deep of the earth crust. The rocks are formed under the deep condition with a high temperature and along with a high pressure. So they are become together and form a deep condition to form a plutonic condition. So the igneous rocks are comes under a plutonic is formed in a deep condition with a coarse grain. Hypabyssal and the volcanic rocks are fine grained to glassy. So hypabyssal also a medium grain to low grain. Okay, and the volcanic rocks are a fine, very fine grained to glassy structure. That shows a volcanic rock. Volcanic rocks crystallize at the surface, and the hypabyssal rocks crystallize at a shallow depth. It's not. It comes. Hypabyssal rocks are comes under upper volcanic rock and the deep of plutonic rocks. The intermediate sector is called hypabyssal. So the hypobasal rocks contain the grain size of medium to low. Okay, medium to low grains. If the igneous rocks are contained, they are classified or they are origin at the hypobasal region. The hypobasal rocks are formed under the condition of shallow depth. Okay, hypobasal and the volcanic rocks are fine grained to glassy, and the volcanic rocks are crystallized at the surface, and the hypobasal rocks are crystallized at the shallow depth. Typically less than a kilometer. Typically the hypobasal rocks are formed under the less than a kilometer. So example, the hypobasal rocks are formed in 800 meter or 500 meter. So these are the examples. Next, because the grain size of an igneous rock is determined in part by the cooling rate of the magma, and this is a function of both of magma temperature and the ambient temperature of the rocks into which the magma was emplaced. Okay, which the magma was emplaced. Magma is depends for every rock chemical composition. So magma also important. Next, the grain size. Grain size is generally increases with the depth, but there is no specific depth associated with the transition from plutonic to hypobasal rock. Okay, the grain size are basics of the origin. So the plutonic rocks have a coarse grain, hypobasal rocks have a medium to fine grain. Also, volcanic rocks also fine grain to glassy structure. The examples of the volcanic rocks are obsidian. Obsidian is a great example for a volcanic rocks. With the depth, but there is no specific depth associated with the transition from plutonic to hypobasal rocks. In addition to classification according to the grain size, the general composition of a rock can be described using the terms felsic, mafic, or ultramafic. Okay, the magma temperature or magma composition is based on, they are categorized under three types. They are called felsic magma, mafic magma, or ultramafic. It becomes a felsic rock or mafic rock or ultramafic rock. Rocks rich in quartz, feldspar, or feldspatite are the very light colored minerals are there. Okay, that's happen in felsic. The rocks rich in quartz, feldspar, or feldspatite. These are the light colored, very light colored minerals, and they are classified in felsic. The term felsic combines a part of the valse feldspar, the feldspatite, and the silica. Next, the dark color. First, we discussed about a light colored mineral or associated in the rocks that becomes a felsic rock. That examples are there. So, granite also example. Next, we comes under dark colored. Okay, light colored minerals are there. There comes under felsic. What about the dark colored rocks? Dark colored rocks rich in ferromagnesium, because the dark colors are comes under the magnesium and the iron content in them. Okay, the iron content and the magnesium are describes, or that together becomes the rock's color. Okay, the iron and the magnesium are both are dark colored minerals. That's why the rocks are comes under dark color. The major chemical composition is example iron or magnesium. The both chemical composition of higher in the rock, that becomes the rock darker color. Okay, the darker color rocks rich in ferromagnesium minerals are called mafic. These rocks are come under mafic rocks. Okay, the term mafic reflects the enrichment of these rocks in the magnesium or iron. Okay, all are know the chemical composition of iron is Fe. Very good. Next, ultramafic rocks are essentially free of any felsic minerals. Next, we comes discuss about texture. Texture also very important for igneous rocks. Texture is defined on the basis of glass versus mineral grain proportion, the sizes, shapes, and the mutual arrangements of minerals. Perhaps you may have questioning asking about importance of textural and structural studies. Okay, texture and structure both are very very important in the study of igneous petrology. So texture and structure are important. The texture and structure provide an idea about the geological process during the crystallization. If the magma comes under the earth's surface, the magma comes and the crystallization process also taking place, and the magma reaches the earth's surface, that becomes a lava, that lava becomes cool, and the cooled lava becomes a rocks. So these are happening in our earth naturally. This texture and structure provide an idea about the geological process during its crystallization. They also provide us a valuable information about the physical chemistry and the cooling history of the igneous rock. Okay, past is the key to the future. This line was said by James Hutton, who is the father of geology. Because the rocks are also important. The rocks, the previously organized or previously originated rocks are the important clues about the past environment, paleoclimatic studies also. Because if the rocks having lots of shells or lots of any organisms, bones, that's the clue of the organisms are living in that period. So that period the organisms are evolved and how they are destroyed. This history is also very very important. So rocks also important aspect of studying our past history. So rocks plays a vital role in the major history of our geological process. Next, the information about the physical chemistry. So the chemistry also important in the study of igneous petrology. The rocks are how they classified. The rocks contains which composition, which chemicals are acquired in these rocks. All are also discussed in briefly in the igneous petrology. So the physical chemistry also important in the quiet type. Okay. Next, and how the chemicals are formed, how the chemicals are classified, and how the chemical composition are arranged in the specific rock, also discussed in the igneous petrology. So the every rock with the chemical composition also important for study. Information about the physical chemistry and the cooling history of the igneous rocks. Okay, let us consider an example. If you observe a granite and the basalt and compare the physical properties, you will find a distinct difference in the difference. Okay, because the basalt and the granite both are different opposite particles, because the granite are light colored minerals are associated in this rock. Basalt are dark colored minerals are associated in that. So granite are light colored mineral, basalt are dark colored mineral. So both are we take in hand and study directly. We have a lot of differences in them. We will discuss about in the following part. First, we can observe a color. Granite is a light colored mineral. Okay. In other words, they are called as leucocratic. Leuco means without color. Leucocratic. Whereas the basalt is a dark color. We always discuss about the basalt. The basalt is a dark colored mineral. So the basalt are dark colored mineral or melanocratic. Melano means dark colored. So the melanocratic comes under the basalt in the appearance. First we see the rock. We firstly see the color of each rock. So the color discussion, granite is a light colored mineral. So the rock comes very light color. The basalt is a dark colored mineral. So we see in our naked eye, basalt is dark colored mineral. Okay, first we discussed about the color. Next, the grain size. Granite is a coarse grained substance. Okay, because the granite is formed in the plutonic region. If the plutonic region, the rocks are formed, that the grains are coarse to medium. So granite comes under the plutonic condition. So the grain size are coarse in the granite. Whereas the basalt is a fine grained. Okay, basalts or volcanic rock. They are comes under volcanic to hypobasalt. The hypobasalt to volcanic, the grains are very low, so they are fine grained or sometimes the glassy. Basalts also sometimes we seen in a glassy structure. If the basalts are in glassy structure, they are directly comes under volcano as a lava. That lava is comes in the earth surface and becomes a cooling, so that becomes a glassy structure. Okay. Next, the grain size is discussed always. Granite is a coarse grain, whereas a basalt is a fine grain or sometimes a glassy. Mutual relationship. Okay, these are the difference between them. Any other mutual relationship between them we will discuss in this content. Mutual relationship. In case of granite, the crystals are large enough to be seen with the unaided eye, but it is not possible in the case basalt. Okay, in the crystals formation in the granite is we see in our naked eye. They are prominent, so we can see them. But in basalt, the structure also glassy, very glassy to fine structure. So there is no crystals seen in our naked eye. So we can see them in a petrological microscope. Okay, they enough to see with the unaided eye, but it is not possible in the case of basalt. Okay. However, many more unraveled differences can be discerned with the granite and basalt are studied under the petrological microscope. These are petrological microscope. Petrological microscope is very useful for determining the mineral arrangements and what are the minerals are there present in them are very useful. So the petrological microscope were seen in only by through the slides. We hope that the concept of granite and the basalt that display different texture is clear to you now. Now, does the texture help us to identify different rock types? The term texture is applied to megascopic or observed hand specimen with the unaided. If we see the crystals or mineral arrangements in the rock directly unaided eye in the hand specimen, this is classed as megascopic. If the rock, if example volcanic rocks are microscopic, because the volcanic rocks having very fine grained particles, so we cannot observe them as crystals or minerals in an unaided eye or naked eye, because the minerals are very important, because the minerals are very fine, so we observed in them in petrological microscope. Okay. Next, as well as, so the term texture is applied to megascopic as observed in hand specimen with the unaided eyes. Okay, as well as microscopic features as observed in thin section under the microscope. Okay, if the microscopic features, if the rocks are fine grained particles to glassy, their mineral arrangements are not visible in unaided eye, so we can refer the petrological microscope. So the petrological microscope, if we study the rock in a petrological microscope, that is called microscopic feature. Okay, microscopic features. So we discuss in the through the slide in the petrological microscope. We have already discussed that the texture of an igneous rock represents intimate relationship between the mineral grains and the glass. Okay, mineral grains and the glass are the mutual relationship. Let us discuss the following texture elements with reference to igneous rocks. First, crystallinity, this degree of crystallization. Next, granularity or grain size. Next, shape of the mineral grains. Next, mutual relationship amongst the crystal and the glass. As well, we have learned that the igneous rocks comprises of crystallization or crystallized as well as non-crystallized components. Study of shape of crystals and mutual relationship between the mineral grains and the glassy material or matter is described as a fabric. Thus, fabric is defined as the arrangement, orientation, and the mutual relationship of mineralization or mineral grains or crystals and or a glass. Even glassy or also represents these of the fabric. Fabric is a non-compositional property of rock. Fabric is a non-compositional property of a rock. Comprises a texture and texture both. So fabric is comprised in both texture and texture, both of them. Next, we will discuss about crystallinity. Crystallinity or degree of crystallization refers to the degree or amount of crystal formed during the presence of solidification of magma. If the magma is solidified, the crystallinity, how the crystals are formed, in when the temperature the crystals are formed, are described in the crystallinity or a degree of crystallization. So, the crystallinity or degree of crystallization refers to the degree or amount of a crystal is formed during the process of solidification of magma. The igneous rocks may be composed of the crystals, partly crystals and partly glassy matter or totally a glassy matter. If the igneous rocks are composed with partly of crystals and partly of glassy, their matter are totally defined as a glassy matter. Degree of crystallization is measured by the ratio, because the ratio also important for crystallization. We can take a degree. If the partly crystals and partly glassy matter are totally a glassy matter, we know degree of crystallization is measured by the ratio between the crystallized matter and the glass in an igneous rock. The ratio between the crystallized matter and the glass in an igneous rock, it is the modal or a moral percentage of igneous or mineral grains relative to glass, or varies between 0 to 100% on the basis of the crystallinity or degree of crystallization. Textures of igneous rocks are grouped as 1. Because the textures are briefly discussed, so the texture comes grouped as 1. First one is holocrystalline. If the rocks are entirely composed of crystals, they are called as holocrystalline simply. Okay, what is the difference? What is the definition of a holocrystalline? Here we go. The prefix holo implies entirely or wholly composed of well-defined crystal spaces of constituent minerals in the rock. Example: orthoclase in a granite. In the granite rock, orthoclase are present. The orthoclase grains are wholly present, so they are holocrystalline. Example is orthoclase in a granite. Next, augite mineral in gabbro. In a gabbro rock, the augite minerals are variously wholly present, so they comes under a holocrystalline. Next, holocrystalline texture is seen in plutonic rocks. Plutonic rocks have a coarse grain. Okay, so the crystals are prominent in the unaided eye. If we see the rocks in unaided eye, they are formed from the plutonic rocks. We can see the holocrystalline, how the whole crystallines are formed in that one rock. Next, hemicrystalline. Hemicrystalline or microcrystalline. When the rock comprises partly of crystallity and partly of glassy material, if the rock are partly composed of glassy or partly composed of crystalline, they comes under the hemicrystalline or microcrystalline. Example: dolerite, basalt. The rock is known to exhibit hemicrystalline texture. Okay, this is mainly observed in the rocks which are crystallized near the surface or at intermediate depth from the surface. So what are the microcrystalline? Because in the volcanic rocks, all the minerals or all the grains are very fine to glassy. So the hemicrystalline and microcrystalline are seen in volcanic rocks. Example, very examples are obsidian. Okay, the surface or at intermediate depth from the surface. Okay, the other synonym term in use are merocrystalline or hypocrystalline. These are other nicknames which are related to hemicrystalline or microcrystalline. The third one is holohyaline. The rocks are exhibiting this texture are entirely made up of glassy matter or non-crystalline matter like crystallites and microlites. They are comes under the holohyaline because the glassy matter or non-crystalline matter, example crystallites or microlites, their resolution. Okay. Next, the results when the rate of cooling is very rapid, the texture is mostly seen in volcanic rocks. This okay. We discussed about the volcanic rocks in previous content because the volcanic rocks are seen very horizontal cooling is very rapid. The lava is comes under the earth surface and becomes the cooling is very fast. So the temperature will be decreased in the lava. So the cooling process is fastened. This holohyaline texture is mostly seen in the volcanic rocks. These are the examples I'm telling now. Examples of the holohyalines are obsidian, pitch stone, and nephelinite. Okay. Next, the granularity. We have already discussed about the crystallinity. Now, let us introduce you to few important technical terms related to granularity, a grain. Okay. Grain size or granularity in igneous rock shows a wide variation. It varies from a meter size, example pegmatite, okay, to few centimeters to even greater than 0.01 millimeter size or microlitic or sometimes even glassy are found in a volcanic rock. Generally, phaneritic or aphanitic terms are used to describe coarse and fine-grained rocks. Okay, aphanitic and phaneritic both words are very important. So they are classified to describe the volcanic rocks and fine-grained rocks. Respectively, coarse-grained crystals can be seen with unaided eyes and mineral grains in rocks are identified easily, whereas study of fine-grained materials in rocks requires petrological microscope for their identification. Okay, next the synonym terms for aphanitic texture are hyaline or glassy texture. Okay, I repeating, aphanitic texture, the synonyms are hyaline or glassy texture. The alternative terms used for phaneritic and aphanitic rocks are pyric and apyric respectively. The another terms used between phaneritic and aphanitic are pyric or apyric respectively. So first we discuss about phaneritic rocks. In this rock, mineral grains are large enough to visible in the unaided eye. Such types of texture are commonly associated with the magmatic intrusions and they reflect crystallization at low degree of undercooling temperature. Phaneritic texture also indicates a low rate of nucleation formed under plutonic condition and they emplaced on the surface due to upliftment. Phaneritic texture is classified into following subtypes. They are referred to as fine grain. Fine grain, they are less than only 1 millimeter. What are the grains are less than 1 millimeter? They are comes under fine grain. Medium grain, they are between 1 to 5 millimeter. They are comes under medium grain. Coarse grain, which are the grains are comes under 3 millimeter to 5 millimeter or 3 millimeter to 5 centimeter. Also comes under a coarse grain. Very coarse grain. What are the grains are greater than 3 centimeter or comes under a very coarse grain. Next, the rapid cooling of lava flow being in the contact air or water results in a fine grained or glassy rocks. Their grain size are less than 1 millimeter. The cooling in superficial rocks such as the dikes and the silts is relatively slow as it takes place under a shallower depth that results in medium grained rock. 1 to 5 millimeter. Large igneous intrusion at much deeper levels undergo very slow cooling that results in the formation of coarse and the very coarse grained igneous rock. The example is a very good example for this is pegmatite. Next we discuss about aphanitic rocks. They are fine grained and have two small crystals to be identified with the unaided eyes. or even with the help of hand lens. They are further classified into two subtypes such as the microcrystalline. In this microcrystalline, in this the grains are visible only under the microscope. The next one is cryptocrystalline. In this case, only felty mosses is seen in, and the mineral grains are not visible under the microscope. They are classified as cryptocrystalline. Next, shape of the crystal. Let us discuss the three important terms: euhedral, subhedral, and anhedral are the resulting texture that are universally used to describe a relative proportion of the grain shape. First, one euhedral term is used for the mineral grains which possess fully developed granite or granocrystal outlines. All the phases are perfectly or near perfectly developed, they are formed. Next, idomorphic and automorphic or equivalent terms used for euhedral grains. Next, panidomorphic granular texture. Example, they are a own morph shape. Compress majority of grains with a euhedral shape. Example is pegmatite. The second one is subhedral. Subhedral refers to the crystals formed with the less or partly developed crystal phases of grain boundaries. Hypidiomorphic granular texture, they are hypo, less or below. Consists of the dominantly of mineral grains. Next, with partly developed or a subhedral shape. Example of this comes under a gabbro granite. Okay, thus hypidiomorphic granite or comes under the mostly found in the commonest and granular texture, also called granitic. Okay, this is mostly found in a granite rock. So third one is anhedral. Anhedral, the term is used for mineral grains lacking crystal outline. When majority of the grains are anhedral, resulting texture is known as allotrophic, which is granular texture. Example, allotrio. Okay, also called as the phenomorphic granular texture. Example for this is uplight. The texture are also called aphytic because this is the best developed in uplights. They are a hyperbizal equivalent of granite. Okay, next, mutual relationship between the crystals and non-crystalline materials. We have read that apart from describing the shape, fabric also including mutual relationship of crystal and the non-crystalline matrix or glass. It has been discussed under two groups: equigranular texture and inequigranular texture. Equigranular texture, when the majority of the grains are the equal size, so it is said to have a equigranular texture. Example is for this equigranular texture is granite and gabbro. It has been grouped into three subtypes. They are microgranitic. It occurs in fine-grained rocks where shape of the grains are mostly anhedral or subhedral. And next one is orthopyric. It is a fine-grained rocks. Grains are mostly euhedral. Next one is felsitic. Its grains are very fine or microcrystalline or cryptocrystalline. Okay, next the inequigranular texture. In an equigranular texture, we discussed all the grains are equal in size. In inequigranular texture, in an igneous rock, if the grain size difference becomes so pronounced that one set of grains is distinctly larger and associated with another set, which is much finer in size, then it is termed as inequigranular, which is much dull in size, much finer in size. Okay, that's why they are termed as inequigranular. They are following types: porphyritic, porphyritic texture, poikilotic texture, intersection or intergranular texture. Usually, there is a marked difference in the grain size of a rock, but if the variation is large to smaller in systematic and gradual, then it is known as seriate texture. Intergranular texture. The mafic rocks like basalt often shows a variety of textures depending on the mutual relationship between the grains and the ground mass, which comprise mainly plagioclase, pyroxene, and glass. The volcanic glacis may be replaced by secondary alteration products like palagonite when it corners of randomly oriented plagioclase layers touch each other to form a network, and the polygonal interstitial spaces are filled by granular anhedral pyroxene. The texture is known as intergranular texture. The next texture is intergrowth texture. Intergrowth texture results from intergrowth, which means the state of interlocking of grains of two different minerals. Intergrowth texture results due to the simultaneous crystallization of two mineral components of the magma at the particular temperature, or due to eutectic crystallization of the two mineral components of magma at a particular temperature. Okay, next the graphic temperature, graphic texture. Graphic texture is commonly found in granite. So if the granite have which texture, we go for graphic texture. Granites and results from the intergrowth between quartz and orthoclase. Next, the magmatic texture. Magmatic texture results from the intergrowth of quartz and the plagioclase. Usually, oligoclase also takes place. Next, the corona texture. It refers to those resulting from reaction in the magma and exhibit a concentric arrangement of characteristic minerals. So we can discuss lots about in this e-content. I hope this is useful for you guys. Thank you.